Hey everybody, this is Larry. This is day 17 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. So I, sent whatchamacallit? I hope you like donkeys. I like donkeys. I don't have it. Maybe I'll show it tomorrow. But I have a donkey keychain. I went to the donkey sanctuary in Aruba. Loved it. There were donkeys hanging out. There were peacocks hanging out. There were chickens just hanging out. And I don't know. I would enjoy it. So if you ever in Aruba, definitely spend 20 minutes there. It'll be fun. There's so many donkeys. Just play around with them. Okay. Anyway. I don't know why I was telling you this, but I am back in New York and it is a little bit chilly today, so I'm just trying to figure out what's up. And today's problem is, let's do Leetcode, right? Is that what you're here for? Finally, we have a hard one. We haven't seen a hard one in a while, or I don't remember it maybe, so hopefully this is exciting. Today's problem is 968 binary tree camera. So we're given a root of a binary tree. We install cameras on a tree node where each camera can monitor its parent, itself, and its immediate future. Return the minimum number of cameras to monitor all nodes of the tree. Okay. So this is going to be dynamic programming, a little bit tricky, of course, but yeah, but definitely, just about figuring out the recurrence and what's a better way to figure out a recursive thing than having a binary tree. So then the question is, how do you break it down, right? One thing is that there are only a couple of things we have to consider, which is that, let's say we were trying to minimize a node, right? What do we care about? Well, if we want to minimize the node, let's see, node.value 0, 0 always, okay. Oh wait, what is zeros for? Oh, it's just having a node at all. Okay. It's a little bit annoying just because caching by node is a little bit odd. Though I guess technically speaking, you can maybe modify it so that yeah, I mean, we can do a couple of things. Some of this is going to be Python specific. This is some hacky. But looking at a node, what are we trying to do, right? Let's say we're given this tree and we're looking at a node. Well, how many different states can it be? Well, the assumption here is that the children don't have cameras, right? Because we haven't done the recursion yet. So then the other thing is whether the parent has a camera. So I think that's only two states, right? Parent has camera and the node currently does not, right? So then now from that, I think we're able to do this recursively. Of course, we should cache. Yeah, I think this should be good because they have different memory. Because I don't think that there's anything weird here. But yeah, let's just say we have a lookup is equal to a thing, right? We'll actually do this later. Let's say this is the case where we turn the minimum binary tree cameras where number of cameras where the parent has a camera or not, right, on this subtree. And the reason why we care about whether the parent has a camera is because, well, if it has a camera, then this current node doesn't need a camera. It could if you want it, but it doesn't have to. But if the parent does not have a camera, you need it to have a camera here, right? That's basically the idea. And then maybe there's an extra thing for checking out the root or not. I think that those are the ideas. The implementation is a little bit trickier, so let's think about this, right? So let's say if node is none, then we turn 0, because if there's no node here, then there's no cameras needed, right? I think one thing that I'm a little bit worried about is making sure that we handle the root node better, right? Because the root doesn't have a parent, so we have to be careful there. But I think that we can be careful. We've been here. We have all the time. Maybe not all the time, but we have reasonable amount of time. So thank you for watching. But yeah, did I say step away? Hit the like button, the subscribe button, join me on Discord, and check out my binary tree cameras. I don't know. Okay, so then now, so let's just say we handle root in another place. It's okay. If parent has camera, we don't need a camera here, but we can try one, right? So then now min node of so then here, what does that mean, right? That means that we want to add up the sum of all the children. So is it just, oh, it's a binary tree. Okay. I was actually, this doesn't actually need to be a binary tree question. It could be like a n-ary tree problem, which is why I actually forgot, or I was thinking about it in terms of an n-ary tree. So that's why I was like, wait, how do I figure out how many children do I have? Oh, it's a binary tree, right? So then here, that means that min node of node.left true, because we're using one camera, plus min node of node.right also true, plus 1, right? Because we're using a camera, so here. So best could be you go to this. Or we don't put a camera here. And then here, then we just node.left false plus min node of node.right, right? So this is going to be min of best and this stuff. Yeah. Oh, and this is false. Whoops. If parents do have a camera, sometimes I write this a little differently. Maybe I could have done it, but yeah, if the parent does not have a camera, then we need a camera here, right? We want to return best. So then here, okay, maybe I could call this add camera here, like maybe something like min cos add camera here, and then here it will be min cos no camera here, not add camera here. Let's go to this thing. And then we return min cos add camera here, min cos not add camera here, right? And here, if the parents don't have a camera, then you have to add a camera. There's no way around it. So then we can, I'm just gonna be lazy and copy and paste here, and then we return min cos add camera here. So then the tricky part is that how do we set it up, because the root doesn't, right? So then here we can just go straight to have both cases, right? So root has camera is equal to min node of root.left true plus min node of root.right true plus 1, right? And then root no camera is equal to min node of root.left false plus min node of root.right false, right? The idea here is that because you're always going to be forced to add a camera between adjacent nodes, essentially, this should be good. And of course, if you were very mindful, also let me, yeah, if you're very mindful, you'll notice that this is exactly this. But sometimes it's okay to you know, like maybe you could set it up, and that's fine. We did it that way, but this one is more explicit, and you can always fix it later. Again, we don't do dynamic programming yet here, but we can and we will. So this looks good actually. I mean, that could mean anything, but yeah. So then now we have to add dynamic programming or memorization. Why? Because you try to figure out if you know what the complexity of this without dynamic programming. But for memorization, I can tell you this, right? Node, there are n nodes, right? Parent has camera is true false, so that's 2, right? And of course, the time complexity, as I always try to focus on this video or on these daily videos, is that it is just because I think people have struggled a lot with explaining the complexity, but it is just total time. Oh, sorry, total time is you go to total number of inputs over, times time per input, right? And here number of inputs is equal to 2 times n, or O of n, roughly speaking. And time per input, well, we only do, a couple of operations each, so this is going to be equal to O of 1. So total time complexity is O of n. And space is going to be the same idea. You have O of n inputs, you have O of 1 space each, so O of n space. The way that we're going to do it, I'm going to do a little bit lazy today, just because it's a schlep. But try. So one thing I would caution about this is that there is, for bigger n's, maybe like, I don't know, 100,000 or something like that. This will be a little bit slower on the lookup, so I would definitely be careful about it. But yeah, so I could do something like parent has camera has in lookup, then we return lookup of. Basically, this is just looking at a hash table. If the input is in a hash table, we return it. If not, we do all these things and then we return it, right? So lookup of is equal to this. I'm writing it very awkwardly, but you get the idea, hopefully. Yeah. Right, that's one code again, just for typos and stuff. Looks okay. Let's give it a submit. Hopefully this is good. I got wrong answer before. Hopefully I don't get it wrong. Oh no. Huh. Oh, did I make the same mistake last time? No, I made a different wrong answer. Huh. Why did I... Wait. Oh, this is right. Yeah, I mean, this is basically me I set up my root case wrong, which is, I guess, why I didn't do it here. How do I fix this? Let's see. Let me think about I'm trying to think about whether I need to change my root case, right? So I think this can only happen. This can only happen if we have at least one node on the left and the right. So I guess we can do it. Oh, and also we have a similar issue, I think, here anyway. Because, well, here, this one is fine because if the parent has camera, we don't have to put a camera here. This node is satisfied. But here, the parent doesn't have a camera. Okay, so that's good too. So I guess this is only applying to this, right? Of course, we have to fix the thing. So let's just say infinity. Sloppy. But yeah, we didn't. Or by we, I mean me. I say we, but oh, this is or, because we only need one of the children to be a thing. Wow, very sloppy today. But at least that time it was caught there. Yeah, so basically what I was doing is that I think I was just rushing it a little bit still on the case on the root. And of course on the root, the assumption was that if you don't put a camera here, you can force your children to have camera, because here, if this is forced, we force them to have it. But of course, and it only applies on the root, where if it doesn't have any children, then there's nothing to force it to add, thus filling this current node. Actually, I think is this still wrong? I think it may still be wrong. I think I'm just messing this up here. Wow, this is a hard one, because I think I have a case where, if you think about it, maybe I just watched this. But if you have a linked list type thing, where let's say we have like a 6 node linked list, that's a binary tree, but it's a linked list, then I think I may try to put one here. But because this one is a 0, I think I might also try to put one here, which I think is not right. So wow, okay. So I definitely underestimated this problem a little bit. So let me think about it again, and also let me put this case in here. Tree visualizer. Actually, I think this is the same as this one. So, except for it's a little bit different, because now we want this, but with an additional 0. Yeah, and here I think the answer is 2, but I think my answer would be 3. Yeah, so this is wrong, huh? All right, let me slow down a little bit. I thought I had one because I was thinking about a similar problem, but clearly this is wrong in multiple ways. So I'm glad that I didn't yeet another wrong answer for this one. But let's see. Maybe I guess I just need one more constraint, which is that because now, so what is a state, right, in dynamic programming? And the thing with a state is always just thinking about like every input has to be the same, right? Here, the difference is that if I look at it here, is that the inputs are not the same, right? Because let's say we put a 1 in the, like let's say we put a camera on a second node here. I don't know what I'm pointing at, you can't see, but we put a camera on a second node here, right? Then on the 4th node, it doesn't differentiate enough about, it just assumes that the parent, because the parent doesn't have a camera, which is true, but there are also 2 ways to differentiate, right? Whether the parent is covered and the parent is not covered, and both of them have different scenarios. And I kind of messed up here. Wow, I think not gonna lie, I don't have excuses anymore. I'm just really bad at these things. I don't know. No, I'm just kidding. But I am watching a little bit because I am trying to watch the Warriors game, and I think that has kind of sped me up a little bit. But yeah, but okay. So then that means that we have to add parent is covered, maybe. And then now we have to think about the cases again. I was wrong here, so. But in terms of the memorization, it's pretty okay. We just have to do the same thing again. Let's clean this up first. There are cleaner ways to write this, but unfortunately I did not write it that cleaner way. So that's why there's a lot of copy and paste. Maybe we could talk about that in a little bit. Okay. And then now we have to go through all these scenarios. So that's one thing about dynamic programming or memorization, is about just enumerating every case sometimes, or a lot of times. So what I want to do here now is, okay, if parent has camera, then what happens? Well, if parent has camera, parent is also covered. So I think we don't actually have to change anything here, right? Because, yeah, because this parent is going to be covered no matter what, because the parent has the camera, right? So then, yeah. Okay. And then now we have to think about, okay, let's see, right? If parent is covered, then we actually don't need to put a camera here, right? So here we forced it, but we actually don't need to. So let's, I'm going to cheap again and then do a copy and paste. Except for that, the conditions are different, right? So because now, if the parent is covered, what does that mean? If we put a camera, then obviously the parent will be covered. But otherwise, if we don't add a camera here, then I need my children to put a camera, right? So then else we put a camera here, and that would be good. Yeah. So the difference is around this base case. So we have to be careful here. I'm going to do some refactoring because this is way ugly. And also this is wrong. So let's see. If this is true, okay. And also if not, this is false. Hopefully this is right. Okay, let's give it submit, and then we'll refactor afterwards. If, wow, I am very sad today. What is this? I got it right last time. Maybe I just missed a case. What did I returned 1, but I expect 2. Huh. Okay. So that means that I add here, and then oh, now we have to go back to what we did before with having a children. Okay. I'm sloppy today. Sorry, friends. The idea is correct, but execution has been terrible. Hopefully, I get this out of the way before, later. But the idea here is the same as before, which is that now you can, if you think about it here, you can think about removing the first 3 nodes, right? Because you put a camera in the second one, and then now the first 3 nodes kind of cancel. They all covered. But then now you have a new root in 0, and then in that new root, you're forced to do it if you don't have any children, right? So that's basically the idea. So if the parent is covered, then we don't have to put a camera here, but we don't put a camera here if it has a child. So we have to write something like if node.left is not none, or node.right is not none, right? And that's basically the idea. Yeah. This is very yucky. We will refactor this because this is not acceptable to me in terms of cleanliness. Let's hope this is right now. Wow. Wow. Sorry, friends. Sorry that you have to see this. That's what happens when I'm rushing it. Okay, then I put 3, but the answer expected is 2. You have 1 here, 1 here. Why did I put 3? Which 3 do I think is no bueno? So if I put 0 on top, then I have 2 more. Okay, that seems fair. If I don't put 0 on top, oh wow. Okay, I see what's happening here. Wow, why there's so many? Maybe I'm thinking about this wrong because there's so many cases. But the idea here now, and this is hopefully maybe in my mistake, you can learn how I look at these things and look at the debugging, right? But the idea here is that if wow, how am I wrong by so much? Is that basically if I have looking at this root, let's say there are 2 cases, right? One is we put a node on it or a camera on the root, that's fine, whatever, same thing. Let's say we don't put a camera on the root, then what I'm doing is I'm forcing both of my children to add cameras, which is not correct. What I need is 1 to do it. So, wow. So here, I mean, a lot of this is case analysis, but I'm feeling like this is feeling yucky. But basically, the idea is that this only has to be true for one of these, right? So what I mean by that is that if root doesn't have camera, I just analyzed it wrong. But if root has no camera, then what happens? Well, either the left has to have a camera or the right has to have a camera. But right now I'm forcing it to be both. So it's either this, right? When node of root dot right, the force but true. But I guess we can. Yeah. So this is if the root is at the camera is at the left, and then we can also do wow, really like missing a lot of cases. I'm curious what past Larry did, because and then maybe just for exhaustive purposes, just do the one where both is force, right? And then we have to do the same here, right? Because only one of them is needed. If we don't put a camera here, then we need yeah. Right. And again, we will refactor this, but yikes. I'm trying to, because this is messiest. Oh, hopefully this is right now. I have to go for the cases maybe. Okay, now I'm being too optimistically wrong. I think the answer. I know why. I'm so tired. But the answer is because this price may not be false. So we have to add something like if no dot left is not none, then we force it, and then we don't care about the right. And then if no dot right is not none, then we force to the right. We have to do it for the root too, but I just want to run it real quick. Okay, that looks a little bit better. So if root dot left is none, then we force it. If root dot right is none, then we force it. This is a pretty hard problem. I don't. Past Larry apparently maybe saw a way that I didn't, but definitely a lot of silly mistakes to be had. Still wrong answers though, and I'm getting tired. Did I mess this up? If left is if left is not none. Okay, that's why I was overachieving. Okay, so it's still wrong answer on the second to last case, it seems like. What is the second to last case again? And it thinks that this is a 1 answer. Why is it doing a 1? Am I doing something weird? Oh, I actually looked. I copy and paste this wrong, so this is why. Okay, let's make this false, and then this we make true. I think that should be good. And as you can see, the amount of fixes that I have to do means that there's something wrong with the code, right? On a minor thing. Whew, 880 days, really tough earned one. The analysis is still okay. Here, you look at the time analysis, you just have to add another parent is covered, if you will. True, false, which is 2. Technically, this is 4, but there's only 3 possibility maybe. So, or maybe not. Maybe I'm wrong. But yeah, let's change the code real quick just for updating. I'm also curious how I did it last time. Did I just really enumerate them? Wow. I guess I really just enumerated them last time, but more better. Yeah. First, let me do this key is equal to this thing, so so we don't have to keep seeing this thing, right? And then now we just have a best, so that's a little bit more thingy. Yeah. And then here, yeah, let's do this is fine. This is fine. And then now we can remove this, put this here, and then yeah, set this as equal to best. Yeah, whatever, just for symmetry reasons. I mean, this one isn't hard per se, but it's very easy to get a lot of stuff wrong, as you can see. So that's a little bit sad on my end. Yeah. All right, let's run this real quick right now. This is slightly better. Oh. I mean, I kind of wrote it the long way because I wanted to be clean on the explanation, but yeah, no bueno. But the thing that we can, it seems that we always do is that we always do this thing, so we can take it outside. We always add a camera here because why not? It would just be, it would just probably be suboptimal most of the time, but yeah, that means that we don't need to do this. And this code is, yeah. Yeah, I think this is okay. Oh wait, no. I think best needs to be this to begin with. Yeah. Okay. Uh, yeah, that's. I mean, we can probably clean up a little bit, but to be honest, I don't really have a great explanation here. I'm gonna show you the code here on top and on the bottom. I'm gonna give it submit again just so we can see. But yeah, the key thing here is just listing everything, right? It's there are a lot of possible cases. You just have to be really careful about it. Seems like I was doing the same thing last time, but I was more careful for some reason. Uh, hmm. Wow, Larry did come to it a little bit earlier last time. Today, not so much. Yeah. Anyway, that is all I have. And I was kind of weak on coming up with examples. Uh, Yikes. But yeah, this is all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.